Let's check. Jack, you with this?
Yep.
Cool. Okay, so on this one, we're looking to see which, or if this guy should switch to a new service. And I want you to think through these kind of algebraically when we do this. So it says he pays 95 cents per song with his current service. So maybe call this like cost. And we'll use the variable C. And so in this plan, it's just 0.95, and let's use S for song. Anytime you have a word problem like this, it's good to use the letter that represents what's going on in the problem. So S for song. Just make sure you don't make it look like a 5 in this case. Okay, the new plan says a new music download service charges 89 cents per song with a $12 joining fee. So his cost for that would be $12 to start. So he has to pay that right away. Plus a cheaper rate per song. So essentially that $12 is kind of buying down your per song rate a little. And this kind of thing is pretty common in retail. Like, hey, if you pay a membership fee, you get lower rates. If not, then it charges you more. Okay? Like, for example, if you buy prepaid wireless service, it's more costly per data gigabyte or per text if you do it that way, versus paying for it through like T-Mobile or something. But you have the freedom to leave. You don't have to have a contract. So there's good things about both. All right, how do we decide if he's gonna switch? It says, should Cameron switch?
See what S equals.
Okay, yeah? I heard you. Good job.
What I found is that if he's listening to more than 200 songs a year.
Okay, awesome. So basically what these guys are doing is saying, hey, when do these equal each other? So 0.95 S equals 12 plus 0.89 S. And then we just solve this equation. Now you could solve it with a graph. Like if you have a graphing calculator, you could plug those two in. This would be one equation, that would be the other. In fact, you could do that on Desmos, which is actually better than your calculator. I'll show you that in just a second, actually. But talk to me about how to solve this. We want to get the value of S. Yeah, Luis?
Do you take off this 0.89S?
How?
Subtract it.
Subtract, okay, good. Yeah, we're going to subtract 0.89S. And I think, double check me, but I think that's 0.06S.
That's right.
Okay? And then, let's see, how about Hudson? How do we get S by itself from there?
Divided by 0.06.
Awesome. So we want to divide because it's multiplied, and just because it's a decimal, that doesn't matter. And we get 200. So, you would tell Cameron, that's the guy here, I guess it could be a girl. You would tell Cameron, if you listen to more or download more than 200 songs, go with which plan? Can you take this off? Put it away. Which plan is better if he's doing like 300 songs? The second one. Okay. And if he's doing less than that, the first one. Let me show you what this looks like on Desmos so you can start getting an idea of what we're doing. Alright. So the first plan was 0.95. This time we'll use X on Desmos. It doesn't have an S. Probably should have put Y equals out front of that. Anybody use Desmos? It's a free, online, and extremely powerful software. So I'm going to get you into using it. It's way easier to use than those graphing calculators that you rent here also, which is cool. So the second one was 12 plus 0.89x. And obviously we're going to have to zoom out. Okay, so somewhere in here, do you see how red goes from bottom to top? Okay, so the red one was cheaper, and then as soon as it crosses over, now it becomes the more expensive one. That point where they cross, I'm not sure if I'm going to be able to land right on it. Yep, there it is. 200 songs. That's what we solved for. We solved for that point of intersection. So 200 songs would cost on either plan would cost $190. It's a lot, huh? Okay. So we are basically interacting with the world here in a real way, because we're looking for where the best deal is, and everybody likes the best deal. Questions on that one? Okay, how about questions on the homework? Any of those you know that you need to do? Or would like me to do? Any of those that you'd like me to do? Okay. So that means you got them all right? Or maybe? How about we check them and then we'll go check that. So we started on 27 this time. So get those out. Here's some answers for you. 27 was -5. Looks like some of you are still shuffling. I'll wait for you. Okay, 27, -5. 28, identity means infinite solutions. 29 was no solution. 30, again, identity, so infinite solutions. 31 was -9. 32, no solution. 33, identity, so infinite. 34, no solution. 35, -2. 36 is 4. And 37, again, infinite solutions. So now that you know how you did on them, are there any that you would like me to do? I would suggest if you feel like you struggled or got it wrong, you should probably ask about it. Yeah.
I guess 33. I kind of got confused on whether it was no solution or infinite.
Okay. Alright, 33. Okay, so let's go ahead and distribute, and we get 6y minus 8. And so if we subtract our y's, which is where I would recommend that you start, we get -8 equals -8. And so that's always true. It doesn't ever depend on x, well in this case y. So that's what we call identity. It just says a true statement all the time. Or infinite solutions, like doesn't matter what you plug in for y. Okay? Yeah, you guys should pay attention on this one. Okay, so 38, we have this little fraction. It's only 1, but we get rid of it the same way. So what's a good strategy? Yeah. Yeah. Multiply the whole thing by 4. But be careful. I'm getting some questions about this. Where do I multiply the 4? Well, It needs to go on everything but the numerator. Okay, so the 2 and all the way across to the 3y. Okay, I'm going to start over here just to keep the equation in the same form. So 4 times 3y is 12y. And then here, do you guys see how it's 4 divided by 4? In fact, if I write it, it's this. Okay, we're multiplying 4 by a denominator of 4. What happens to the 4s?
Go bye-bye.
They cancel. And it leaves 8 minus 12y. And then how about here? 4 times 2. We still have to do that. That's 8. Okay? And then notice that it's 8 minus 8. So then we get 12y equals 12y. And that again is the identity. Okay? If you divide by 12, it will just say y equals y.
Isn't that 12 a negative though?
Oh yeah, good catch. Sorry about that. So here's what she's saying. 8. Oh, and the 8s are, I read it completely wrong.
Yeah, and positive with the 8.
Good job. Sorry about that. Okay, now we're going to add over here. So plus 12 on each side. And that can be reduced. What goes into both of those?
2 votes.
Yeah, 8 goes into both. Okay. Any others? Yeah.
It's 32.
32, okay. Yeah, I could see why you're asking about that one. Alright, what's a good place to start, Maria? Yeah. Okay, we have a fraction inside of parentheses. So I wouldn't recommend like distributing a fraction to get rid of it all the way across, because that's what this does right here. Okay, I'll do it on this side as well. 16 times 4 is 64. 16 times negative 3 is negative 48. And then we have our m. Okay, again, I'm telling you to divide first. 96 divided by 2, and then multiply by the numerator, which is negative m. So what's 96 divided by 2? Yep. 48 times negative m is just negative 48m. And then we get 96 times 1 on the other side. Alright, now what? Aliana, what would you do next? Okay. Help her out, guys. Lucas, what would you do next?
I'm not sure about this one.
Ella, help him out.
Wouldn't you write 48m?
Yeah, so we do want to deal with 48m, but they're both minus already.
So add them together.
Okay, what happens to both sides?
Cancel out.
Yeah, the m's are gone, and it just leaves this statement: 64 equals 96. Good. So that is not true ever. So we say no solution. Cool. All right. If you have other questions, come in and see me. But we're going to shift back to the next topic, which is literal equations. So if you want, grab your notes. We're not going to spend much time on this. It's going to be short, like 20 minutes maybe. of you guys planning on going into math like pretty high at either at Central or in college? Like you're required to do algebra 1, geometry, algebra 2, but anybody thinking pre-calc, maybe calculus? You too? Good job, guys. Even in algebra 2, it's good to be able to manipulate an equation. Okay? In other words, that's what these are. We're solving for letters instead of trying to figure out their value. So here's an easy one. The rate time equation, you probably have seen. This is just an intro. You don't need to write it now. So D equals RT. It stands for distance equals rate times time. How far you travel on I-70 is your speed times how long you're driving, right? 70 miles an hour times 4 hours. You just went. If we did 70 miles an hour times 4 hours, how far did you just go? 4 times 7 is what?
28.
Yeah, and then add a 0. So you just went 280 miles, right? That's distance equals rate times time. But what if you want to solve the other way and you want to know the time? So what we're going to talk about is how to isolate a variable of interest. That's what this means. Isolate means what?
It by itself.
Yeah. So if instead I asked you, how long does it take to drive to Denver? Now we're solving for t. Well, what would I do to get t by itself? Just divide by r. And who cares that we're not getting an actual value for t? Because we're just trying to get it by itself. So then I could write t equals d over r. And now t is by itself. We have solved for t. Okay? So if I said, hey, Denver is 250 miles away, and you're driving 70, averaging 70, now you just have an expression to immediately solve for how long it will take, etc. Okay? Maybe I say Denver's 250 miles away, you want to get there in 4 hours, how fast do you have to drive? Then we would manipulate that and solve for r. Does everybody see what we're doing?
Yeah.
It's a really important skill because it allows you to get things the way you want them instead of just the way they're given. Okay? Like in this case, I could rearrange it to solve for t. Okay? So, simple example. Here's kind of a description. All we're really doing is isolating a variable using our undo balance techniques that we've been doing with equations now for like a week. So our goal is to move things around in order to get that variable by itself. We just don't have to worry about getting its value. So who cares about the value in these? Okay, here's an easy one. I'll put an example in your notes, but not this one, it's too easy. So how would we solve this or isolate A? Talk to me about steps to get A by itself instead of C by itself. Go ahead, Jackson.
Divide by x.
Yes, but not yet. Because if we thought of this as 10x plus 12 or something, what would you get rid of first?
12.
Yeah, so we're going to subtract b. Let's use a different color. Alright, what do I write over here? Like we know now that the b is gone on the left and it's just ax. But what goes over there? Can I write a number? No? So what do we put there?
C minus b.
Just what we did, right? All we're going to write is c minus b. Alright, we want x gone so that a is by itself. Jackson, you said it. What do we do?
Divide by x.
Okay, now be careful. That'll give us a. What do I divide on the right by x? How do I show that? Because I'm not going to get a value. It's not like I'm dividing a number by another number. So where do I stick the x? Not next to, because that would show multiplication more. Oh, we don't want a minus. We're dividing. Oh, did you say below the minus? What did you say?
I just said minus.
Yeah, so we're dividing. Okay, you have two choices, and I think one is easier. Do you agree that I just showed division on the whole left side? I divided the whole left side by x, right? So I can show dividing the whole right side by x like that. And then it's totally fine to leave it that way. Okay, and that would be the end. The other option, which I think probably students will mess up more, is to show the x under each thing, which is okay, either one. And then you would just write it slightly different like this, and that's the same exact answer, it just looks different. So do you see how we have to leave those letters in there, but we're still doing the same algebraic steps, okay? Alright, let's do a little harder one. So let's grab this one to your note packet. I'll give you time to write it before we start. You do need to add the word solve in front of this. So solve A equals all that stuff for C. While you're writing that example down, this is called literal equations. Sometimes they can look kind of weird, but you can still work through them because you guys know how to do algebra. Okay, we want C by itself. So here we go. Step one. Actually, it's kind of hard to say step one. It's just it's like the cycle. So undo, balance until the variable is alone. Undo means get rid of, right? What do we need to get rid of in order for C to be by itself? Yeah.
C, D, and A.
C, D, wait, you said C. A, B.
Yeah.
A, B, and D. And one other thing. And the 4. Okay, we also need to get rid of that. So, put this note. This says divide by 4. How do I get rid of divide by 4?
Multiply by 4.
Yeah. So get rid of it by multiplying by 4. Okay, so we're just going to stick times 4 right there. Can I just do it on one side? Does this just say undo? No, we also have to balance, okay? So we also need to multiply by 4 on the other side. And our new equation looks like this. 4a equals little a plus b plus c plus d. Alright. Now how do you get rid of all those other letters? Again, we're not trying to find C's value, we're just trying to get it by itself. Diego, what do you think? How would we get rid of A, for example? Little a. So it says A is just sitting there positive. How do we undo a positive something sitting there? Yeah, we just subtract. Luis, how would we get rid of B and D? Can we do all of those at once? Yeah, sure. Okay? So we're going to undo A because it's, oops, not with a B. It's positive, we'll say minus A, minus B, minus D. Can I just do that to the right?
No.
Nope. Balance it over here. So minus A, minus B, minus D. And now we have C alone on the right. How does the left side look? Okay, negative A minus B minus D plus 4A. Or you could rearrange those if you keep the signs correct. Okay? C is now by itself. If you can get good at these, I feel like you can solve regular equations even better. Because these are sort of all conceptual. So let's go back and have you try the next one. This one is going to put a little twist in there. But ask yourself, how do you get rid of... I forgot to tell you what to solve for. Solve for M. And then I want you to start over. And see, if you finish that one fast, see if you can solve for B. So I'll give you a few minutes. Okay, this first one, definitely, hopefully, we're able to work through because it didn't involve anything non-linear, which is, well, we're in a linear unit, but I wanted you to try non-linear with this one. I'll get there in a second. So up here, though, this should be pretty just regular. Getting M by itself work is mostly steps we've done. How do I get rid of divided by 2? Okay, so we're going to multiply by 2 over 1 and cancel those. And that cancels the 2 on the denominator. Okay? So can I just multiply one side? No. So 2 times k on the left. And do I need the 1?
No.
No. You can write it, it's not wrong, but you don't need it. Okay. Now we want to get M by itself. What do we have to get rid of? B squared. How? So does it say plus right here? So minus undoes plus. What is going on in between there? Times. How do we undo that?
Division.
Okay, so we're going to show divided by b squared. And now we have M by itself. So 2k over b squared. So if we wanted to solve for the mass with a known kinetic energy and velocity, and which would happen, that very much could happen in your physics or science. Alright, little bit of twist. I want to go through this one real quick, just for fun. We still need to get rid of the half. How? Okay, there's nothing being added, right? Can we subtract to get rid of multiplication and division? Okay, how do we get rid of the 1/2? Everybody, we just did it.
Multiply.
Okay, so we have 2k equals mb squared. Okay? Yep, now we're going to divide. It still says m times v squared. We're going to divide by m. But we are not quite done because this says v squared. We don't want v squared, we want v by itself. So let's see if you know this one. How do you undo squared?
Square root.
Okay.
Then they don't mean what you
He says root it. You said square root. What were you going to say?
Square root.
Square root, yeah.
Then they don't mean what you
It's the check mark looking thing, right?
Yeah, the thing that you
Square root undoes squared. And so v is equal to the square root of 2k over m. It doesn't look pretty, but that's what we do. We just isolate variables. We don't care what their value is when we do this stuff. All right. Don't pack up because I have some things to tell you about tomorrow. So listen carefully. You have your first assessment tomorrow in class. It's a quiz on solving, and you need a calculator. there is a very good chance that you won't pass if you don't have one. You may not share calculators. So if you don't have your own, again, there's a good chance you're not going to pass this quiz. There will be ones with no fractions, there will be ones with fractions, and there will be ones with decimals. Okay? I said don't pack up, I'm still telling you stuff. So definitely on the decimal ones you'll want a calculator, but other ones probably, I don't know. If you're good at it, you don't need it. Look here, you're not packing yet. Ah, this thing keeps shutting my tab down. Okay, those of you who've gotten into varsity, if you haven't, you should have talked to me by now, but I have an solving equations review in there for you that's due tomorrow for this quiz. So it'll help you prepare. Look up there. I'll show you what to do. Actually, I think I can do it with this. When you get in, here's what it will look like. It's going to have this. Probably pretty soon it will be turning red. You click on it, and it brings it up down here. Then you click on the title, and it takes you to the little review. And so hit start. I know it looks grayed out, but you can hit start. And then go through and solve these equations for a review. And I will put that in this as your review grade. Okay? It is due, what did that say? It is due at 1:40 tomorrow, so before class. You have up until right before class to do it tomorrow. Okay? And then after that, we're not going to take the quiz the whole class. After that, we're going to start